Okay, this very important TOK connection. This is a TOK thought. All models are wrong, but some are useful. What do you guys think of that?
It makes sense. I mean, you can't accurately represent everything. Something's gotta be changed or exaggerated or minimized to show you something else.
I think that's an important idea. And I would say lots of models are useful. There's also a lot of useless models, but a lot of models help us make predictions and things, but they're never exact. So, second order differential equations. That means it involves a second derivative in the equation. We did a couple of them last year where it was just a second derivative and you integrated twice. So, a second order differential equation can look like this or that.
K over M.
K over M are just constants. This is a spring system, so K is spring constant, M is mass of the object being moved by the spring. We did some sort of like this last year, where we separated the variables and integrated twice. This year, notice it has a x double prime, x prime, and an x. Okay. This is where they get significantly more complicated. Okay. Air resistance, yes, is an example of something that involves second order because air resistance is dependent on velocity. And the amount of air resistance affects the acceleration of the object because it changes the net force. Yes, he's like, oh shoot. This is connecting to things I learned in physics. Ouch. New notation that you need to be aware of. This is what actually is going to show up on your test for the notation. Dots over it are the same as prime. Primes are what we use in America. I think a lot of the rest of the world uses dots. That we do things differently here. Yeah. I was like, actually, I don't like, once I've gotten used to the dots, I think I like it better than the primes. I'm like, oh, it's a little less sloppy. They kind of do if you're not careful. So I kind of like the dot notation. You will likely see both in college. Yeah, you're at CEI. Um, I was like, you're at CEI, you're not dealing with international professors. You're dealing with East Idaho professors that grew up using Prime. Okay. I never saw dot until this book. And then I had Mr. Ma help me with a problem and he used dots. And it's like, what does this mean? And I think Mr. Klein had seen it once. So does that kind of make sense? These second orders. And we're going to essentially use something that is going to involve, we know that ds is position, right? And ds dt is velocity, correct? And dv dt is acceleration. And check this out. The second derivative of position is acceleration, correct? Well, we're going to be able to replace some things with v's and dv dt's and use a coupled differential equation like we've been doing in 5.16 and 5.17. Okay. So this is essentially just doing the same things as 5.17 and 5.16, but you're given it in a different form. Okay. So in some ways, this is, yes, the hardest section in the book. In some ways, you're not really doing anything that different. So find a model of a swaying skyscraper. We're going to talk about this, how to do this. Okay. This is how to write a base version of a differential equation. Okay. These are the things that are affecting it. Okay. Use x of t for the displacement of the top of the building relative to the upright position. Build a relationship between the acceleration, the velocity, and the displacement based on the following. So the acceleration by the force applied to the building to the is affected by the force applied. Okay. So acceleration is affected by force, correct?
We were saying,
It's proportional to force. That makes sense? The stiffness slows down the sway. This is proportional to displacement. Engineers build dampers in that are proportional to the speed. Speed is dx dt, right? I need another variable. I guess I'll use c. So I have some constant. I have a bx. I have a c dx dt, and I have a, I think I got this right. Okay, force they just called p because k times f, some constant times f. They said they used q instead of b and r instead of c. Does that make sense? What?
in,
I guess my b would probably be negative. So maybe I should have said it slows it down, so that's subtracting based on bx. And there's dampers built in based on the velocity, so it's dampening, so it's minus. It's my constants would just probably be negative, theirs are positive. If I was able to do some work with it, they're not gonna care on an exam. That makes sense? Yeah, I don't believe in subtraction. I keep telling kids this. They're like, what do you mean? I add negatives. And yeah, I'm better at this than most of you. It might be something worth thinking about. Because when you can move things around as long as you move the negatives, positives. Oh, correct. Yeah. That makes sense. We've written a second order differential equation. You have to read what it says. You often have these k times f should be fine. They just simplified it as p. Notice they did define what these are, though.
Do we?
If you're writing an equation, K is you could say P is the constant of wind force, or K is constant times a constant proportionality constant for wind force. B is proportionality constant for displacement of the sway, and C is a poor proportionality constant. They called it a characteristic of the damper. They're showing that the negative sign is working against movement, which makes sense. It's probably better to make them negative. I haven't done a lot of this, so converting second order differential equations. So this is the idea that we're going to say v is dx dt and a is dv dt. So consider this differential equation. Dx dt is equal to v. Change in position relative to change in time is velocity, correct? So my second one, and I'm gonna move it over to the other side so I can put my coupled system together. 3v prime. Actually, let's use dot. Let's use the dot notation just to get you guys used to it. Means the same thing. Plus v plus x equals 0. Now I need to solve for v prime or v dot. So 3v dot plus or equals, I'll subtract the v and the x from both sides. Good so far? Divide by 3. Getting this in what we're used to as a coupled differential equation, or at least semi-used to. Now I've just got a differential equation that I've solved in 5.17. Okay? It's not actually that bad, is it? There's a lot of tricks to these. You're not responsible for coming up with the tricks, you're just responsible for knowing them. Oh, they did dy dt instead of dv dt. They would accept either one. Okay. Now we're going to solve two of them. And then we're done. With learning calculus, or at least with new calculus.
We're all done with calculus. We'll move on soon.
Yeah, you're gonna have an exam in 2 weeks.
We still have 2 more weeks to run off that, right?
You have a week of Revision Village practice questions. Izzy, have you ever been into Revision Village? We need to make sure you can get in today. Because I don't know for sure if they got you an account or not. They might have gotten you an account when they got everybody else one. Well, it's possible. It's possible they didn't because yeah, it's because you're only in one class. Like the TOK kids don't need a Revision Village account. But I'm like, if I ask, I'm sure we can get you one by Monday.
How much is the cost of paper right now?
I have no idea.
The like gold membership. Gosh, this is
Okay, sweet. So I decided I like their review questions better than I like Cognity's. And they have a video of the teacher working through it for every question. Don't try them all first. Okay? Exact same, no. Similar-ish. There should be some similar stuff. They are like exam questions, type of questions. You have 30 of them for the review. The test is I because we're taking off three, I think it's 14.
Oh.
You already did the graph theory questions that I put on it. Because I did graph theory with the last group too. So convert the system of two first order to first order differential equations, and then we will use Euler's method to find an approximate for t equals 2. We'll let the calculator run Euler's method, and then we'll plot the points you used in the steps in the previous to start a phase portrait. We'll also let the calculator do that. So this will say dx dt equals y. So then I've got 2 y dot, because dx squared dt is then y dot, right? 2 y dot plus y plus 6x equals 0. 2 y dot equals negative 6x minus y. To probably make this easier, I'm going to do this as 3x minus 1/2 y. So I'm just going to have them be separated. dy dt. So now let's grab our calculator. We'll probably need this later, so menu. Actually, no, I need to add some pages. So I gotta escape all of this. First, the calculator. I'm going to leave my things here. But I need to erase it so I can actually read what I'm typing. We're gonna go xp of y. I've only got a y there, so I don't need to have x comma y. Colon equals y. And then we'll do yp of x comma y. And that's negative 3x minus 0.5 y. And h is going to be 0.1.
Family uniform.
It told me the step size. And remember that xn plus 1 equals xn plus h x prime n, and y n plus 1 equals yn plus h y prime n. So now we're going to add let's get rid of these ones now. My spreadsheet. And it wants us to, that wasn't what I meant to add. I guess I'll just add a spreadsheet on page 4. This is going to be N. I just need to double check how far they wanted us to go. We've got 2, 0 for, notice my coordinates are X, Y, or X, X prime. And we're trying to go to X at 2.0. X of 0. So this is 0. We're going by tenths. We need to get to 20. And I should always I should always name these things double letters. So it doesn't confuse the A's that are on there with your variables, because there is a column X. Suppose I maybe should have just wrote a formula and filled this. It starts at 2, 0. And then this, remember we start with the equals, xn, the one before it, plus h times xp colon,
A1 plus H for that next one.
no, because this is a coupled one. Because I have a dx dt. There's C1, it was xp for C1 because that's the previous y. No, I don't. It's actually typing on me. So you can see the whole formula down at the bottom of the screen here. Let's put in our second formula and then we'll do our fill. So equals this plus h times yp is yn prime, right? But I have to do x1, comma, that one. So if you need to see it. Does this make sense? Now we're going to do menu, data, fill. And it won't calculate it because it needs both of them. Do that one.
Syntax error during insertion.
And what are we looking for to answer the question? So using Euler's method, find an approximate value of x. So we are looking for an x because y was the thing that we inserted, right? We are looking for an x, so negative 1.62. We okay so far on this? We ready to make our phase portrait? Gonna clear this off the screen. Now we need to go to our graph. So if you need to add a graph, add a graph. I had one here at 1.1. Everybody on a graph. Remember, we are doing this as sequences. Entry edit sequence, and I'm just doing a regular old sequence. UN plus 1. X, remember, is U1 of N. I might be able to use H, but I'm just going to use 0.1 because I know what it is. XN was just Y. Actually, ooh, I wonder if this is going to work. I'm going to try using X prime. I think this is going to work. So since I defined X prime, I can just use these. I don't have to retype the equation. Hmm. Initial value of X was 2 from 0 to 20. And it's not going to work with that. It's not going to do anything because I don't have U2 defined yet. But so all I'm doing, do you see the translation from here to here? Oh wait, so sorry, this is going to have an error. X prime was only defined with Y. So I've got to change that. X prime was only defined to have one variable. It's Y prime that I defined to have the two. So I do have to use what's correct. I'm gonna uncheck that because I don't want display. Everybody here so far. Now, you too. I guess I could use H here because it's still tracking it because I defined it. I think defining these is probably the way to go. So that it's a little easier to fill in the boxes. Initial time, this one was 0.
Okay.
Mm, Mask Mrs. Mail. I think so.
See how it would help us, like, we're,
Just
like,
definitions.
yeah. So, let me see why not.
And like I turn off your ability to save stuff. You will come see me with your calculator before the exams. I will turn it off. I'll take it out for weekends. If you're doing a couple exams in a row, we'll just leave it on for the week. You can feel free to leave it here charging overnight. Okay, have we got that far? So again, I'm gonna hit tab and turn that off because I don't want to see it. Okay. Now we're gonna go menu. And again, we're going to sequence, but now we're doing the custom one. Yeah, we've been doing this anytime we did it this method. So this allows us to show sequence 1 on the x-axis and sequence 2 on the y-axis. So it's taking our sequences and turning them into coordinates for points. And I set this step thing to match. And check out our wonderful phase portrait. I should probably keep going past 20. I think, so it looks like this is probably curling into 0. But yeah, let's see what happens if I go to like 100. So I'm going to press tab. I'm just going to change this. I think I have to change all of them. We'll just do 100. Because the other sequences don't go past that. So then I've got to go back to the other one, the other sequence one, the sequence, and change these steps up to 100
I think 100.
to get it to spiral in.
What is for the game at alpha 0?
It doesn't look like it changed it.
Yeah, it might change.
Yours changed? Mine did not change.
You just need to hit the box.
To show it?
Well, we're gonna change it on the custom sequence.
I did, but I did that first, and I'm wondering if I need to change it again now. It didn't change it there. So it shows it spiraling in. You get the idea though here, enough. I just wanted a little bit more to see it spiraling in. So yes, we get all the same things. And yeah, they've kind of got this phase portrait. I think my window's a little funky here, so if I did zoom 6, that'd probably give me a, what did that, oh, never mind, it's not 6 on this, it's 5. It's 5 on the Inspire, it's 6 on the 84. Zoom standard is zoom 5. So, but we get a nice little phase portrait. I'm really starting to like this calculator now that I understand how to use it for this. Uh-huh. You can do this thing. You can't do the spreadsheet method with the 84. You can do this method, but it's harder. Well, actually, I'm not sure if you can do the custom sequence. You can do the individual sequences. So here's a funky phase portrait. So here we've got a mass spring sections system that is immersed in a thick liquid that stretches 4 centimeters from its natural length and released from rest. Okay, so we stretch the spring. We've got it in a thick liquid, maybe an oil. So this is maybe internal part of an engine type of thing. Okay, the natural length of the spring is 8 centimeters. In this equation, x represents the stretch of the spring from its natural position t seconds after release. The natural length of the spring is 8 centimeters. How long is the spring after 2 seconds? So we're looking at this thing, right? And we'll convert it. How fast is the mass moving after 2 seconds? So we're going to need to write our second order. I need to figure out how the 8 affects this, though. Oh, okay. So we're just going to use that. I see what we're doing. So converting, we're going to start with, want a highlighter? I want a pen. I'm going to start with dx dt equals y. And then we'll do our y dot plus 4y plus 3x equals 0. So the second derivative is y prime, correct? And we'll solve. I'm specifically putting it in the order that I am because we're going to do the eigenvalues and eigenvectors method. And we're going to let the calculator calculate them for us. You guys can all calculate eigenvalues and eigenvectors at this point, right? If you can calculate them by hand, you may use the calculator. Okay? So what is my matrix here?
Yeah, negative.
I'm gonna,
If you put land, be one, zero. Then they one.
no, it's 0, 1.
Zero.
The y's have to match. That makes sense? So some of this. First thing I'm going to do is define my matrix. It has to be 0, 1, -3, -4. And I'm going to store it as, we'll just call it A. You know when you guys have that entered. Now we shall do matrix and vector. B is advanced. Eigenvalues of A. -1, -3. We'll go ahead and get the eigenvectors. Okay, so we have lambda 1 equals -1, and it goes with eigenvector 1, -1. Lambda 2 equals -3, and it has an eigenvector that looks like -1, 3. I'm guessing the book puts the negative on the bottom, so I'm going to check. I think it's easiest to just match. Yep, they put the negative on the bottom. So now we are going to go back to our equation. Switch where that negative is. My equation was the x vector equals AE to the lambda 1 they called it P1 BE to the lambda 2 P2. There's a T here. Sorry, I missed the T. negative t, 1, negative 1. Let's see, what information do I know? The spring is stretched to 4 millimeters from its natural length and is released from rest. That means my initial conditions for t equals 0, the stretch x is 4. Remember, y is representing velocity. If it's released from rest, that means y is 0. The velocity is 0.
Wait, one is released from rest?
So at the moment of release, it's not moving because it was at rest.
Oh, gotcha.
We're talking about that split second before the spring starts it moving, which in physics we talk a lot about split seconds. There is no, if you get you can keep getting finer and finer, but we talk about the initial condition at time 0, it wasn't moving because it was being held until it's released. Which gives us this. 4 equals a times 1 e to the 0, right? Plus b times 1 e to the negative 3 times 0 is still e to the 0. So that's 4 equals a plus b. My second line is going to be 0 because its x vector is xy, right? Maybe I should write that. I don't want clear. The x vector is also always my x, y, or in this case, x velocity. Then I've got negative a e to the 0 plus negative 3b e to the 0. I think it's easiest to just solve these systems a lot of times by hand because they work out very nicely. The a's are just going to cancel, right? 4 equals negative 2b, b equals negative 2. That would leave me with a equals 6. Plug in negative 2 for b, I'd probably use the top equations and solve. So my equation is now vectors on position here are 6e to the negative t 1 negative 1 plus negative 2e to the negative 3t 1 negative 3. Says how long is the spring after 2 seconds? So we'll plug in 2 x. I really just need the first row, correct? Because that's my position row. My second row would give me my that's negative 6. That's going to be, ultimately, this is going to be my change in x. Okay. Y equals negative 6e to the negative 2 plus 6e to the negative 6.
So speak on last.
On the last one?
Just have
So I multiplied by the bottom row of,
Oh, okay.
and then how long does it take? That would probably be a graphing calculator. Let's make sure we did this correctly. And yes, they plugged it in. It is x2 is 0.81. So add that to the 8 and it's 8.81 centimeters. Does that make sense? The x position is how far it's stretched from equilibrium. Unstretched length or equilibrium is 8. It started 4 centimeters stretched out, so that would mean it started at 12. Does that make sense? So I've got a coil spring that's 8. It's stretched out. So this is initially stretched out an additional 4. So that's actually 12. X is giving me the value. Ultimately, the length is 8 plus X. Okay? Or X of T here. It asks how long will it take to drop below 8.1? I'd take my X of T function and I'm looking for when is it less than 0.1. I would just solve by graphing calculator. That makes sense? Find an intersection. Make sure when you do this, you plot your graph. Label the point of intersection. Label the two functions. Y equals 0.1 X of T. That kind of makes sense. I think you're going to have to do some of these for it to really make sense. But that is as hard as differential equations get for this course. I'm sure they get worse if you take the